All right, problem 14, last problem of the day. Choosing mean or median. It's going to basically have you think about when is it best to use mean as your typical number, or in this case, your typical jump, and when is using median better to use as your typical jump. Well, let's get going. It says it's important to look at the distribution of the data when deciding whether to use the mean or the median. Distribution is referring to, is your data symmetrical, or does it have outliers? Is it skewed, or is it balanced? In the year 2008, which represents a typical jump better, the mean or the median? So we're looking at this year, and we're looking at this information. Which mean or median would best represent a typical jump? Pause it now if you haven't made a decision. Otherwise, I'll tell you, it's either. You could use either the mean or the median when your data is balanced or symmetrical. They're going to come out to be about the same. For letter B, it says, what if the 9th place jump in 2008 was very small, such as 160? Redraw your histogram from problem 12 and include this new jump. So 2008 is this histogram right here, and you just have, just sketch it, but you have to include the number 160, so it's going to be somewhere over here, your new data point. Pause the video if you haven't created it yet. Otherwise, continue on. If I was including my new data point, this is where it would look like. I kind of tried to evenly space out and find out where 160 to the 170 bin is. And this is what it would look like. A big outlier. So this frog just jumped not very far compared to the other frogs for that year. Okay, we're moving on. Okay, part C says this. Without using your calculator, make a prediction. How does adding this outlier affect the mean and the median of the 2008 data? So you first have to make a guess or a conjecture. What do you think is going to happen to the mean? Do you think it's going to go up, down, or stay about the same? Also, what do you think will happen to the median? Do you think it's going to go up, down, or stay about the same? Make a prediction right now. Pause it. Otherwise, we will continue on to D. So it says use your calculator to test your prediction from part C. Okay, so we're trying to find the mean and the median for 2008 with this new data point. So it's of 160. So if you're looking at the screen, you are going to be watching this part up here. We're going to add in our new data point of 160. And now we have to find our mean. So we're going to add up all of our numbers and divide by 9. That gives us 217. And the median, now we just have to find our middle number. So we're going to cross out the high, cross out the low, cross out the high, cross out the low, and it will take us to our median, or our middle number, 221.5. So if you then go back and compare it to your prediction, well, what did you think would happen to the mean? If you said that it was going to go down, you were correct. In fact, it went down by quite a bit. It was 224 and change, and jumped down to 217, difference of about 7. And median, you could have said either down or about the same, because it jumped from 224 down to 221, so it did drop a little bit, but it did kind of hang around in the same area, or the same area. And now we're moving on to our final two letters. Letter E says, look at your histogram from part B. Does the mean or does the median better represent a typical jump in 2008? If you haven't answered it yet, pause. Otherwise, continue on. Well, this was our data without the outlier, and then this was our data with the outlier. And which one do you think is a better representation of a typical jump for this year? If I was looking at that data, I would say, you know what? The median of 221 is a more typical jump, just because, there were more frogs that jumped in that zone or in that range. 217 is not as good of a measure, because if you're looking at the graph, there's not as many frogs that jumped that typical length. And why did the mean drop down so much? Well, if you think about it, you were adding in that outlier of 160. And when you added it up, you got 1,953. So, you're adding a low number, and then you're dividing by one number greater. So it's going to bring your whole average, or your typical jump length, down quite a bit. Your median, on the other hand, didn't drop as much, just because, it was going to be between these two numbers, but now it was simply 221.5. And this is a very important thing to know. So the median's better, and the median is better to use when there are outliers present. So if you were to see an outlier, for example, in this case, either 2009 or 2008 with that big outlier down at the bottom, the median's better, and that's because they're resistant to those outliers. They're not as affected like the mean is. The mean is great to use with balanced or symmetrical sets of data, and the median is better to use when you have a data set that has an outlier. For example, this year of 2008, including 160. 2009, it does have two outliers, but the interesting thing about these two outliers is that they kind of balance each other out. It has a very high outlier, and then it also has a pretty low outlier. And that low and that high kind of balance each other out so that it ends up kind of in the middle. That's why you get a mean and a median that are really close to the same thing. All right. I know that was a long video, but hopefully that helped. Stay tuned for day 2.